In this video, I would like to share with you some of my demos and talk about the ASCII graphics engine that I've been working on. This video will be followed by a set of tutorials explaining in more detail how these effects are implemented. So if you're interested, stay tuned. There's something about ASCII art that I find rather appealing. Perhaps it's the creativity, or maybe the blocky retro look. Anyway, the popularity of things like ASCII shaders that turn images into visual representation of text suggests that I'm probably not alone. The initial goal was just to create some silly ASCII effects in Windows console, and I wanted to use high-level language like C#. No graphics APIs, no Windows GDI, just plain Windows command prompt with C# and Visual Studio. What basically started as a small evening after hours project grew eventually more interesting, and I was surprised by the response to my ray margin in Windows console video, with viewers asking me to share the code or do some tutorials. The first step was to get all of the low-level boilerplate stuff out of the way. Then, I added some standard algorithms useful for graphics, typically provided by most graphics libraries, so I thought my engine should support them too. All are implemented from the scratch, including vector and matrix operations. There surely are more efficient ways to implement them, but the goal here was transparency, so others can see how things work and also easily copy and paste the bits of code if they need to. It was also great to revisit some of the core graphics techniques that I use all the time, but they are usually handled by hardware and accessed via APIs such as OpenGL. For example, making rasterization work around the limitations of Windows console, which uses surprisingly slow rendering algorithm, was quite a challenge. But more about it later. I should mention that I've come across some great C++ videos doing ASCII graphics. One of my favorite creators who has plenty of videos covering this subject is One Lone Coder. I really recommend you check out his channel if you are into this type of content. Anyway, in C#, fast console graphics is a bit tricky. Natively available console.write is just too slow to do anything in real time, and there are no obvious alternatives available out of the box. In C and C++, we can access the console via Win32 API, specifically via a set of functions from kernel 32DLL. We cannot do it as easily in C#, but there is a way. We can import and invoke C functions in .NET using interop services. And why do we want to do this? That's because instead of drawing each character on the screen one by one, like console.write does, which is very slow, we want to draw our characters to some sort of text buffer first, and once we finish drawing the entire frame, send the buffer to the console. This is pretty much how drawing works in applications using OpenGL, DirectX, and some other graphics libraries too. Instead of text, they operate on pixels, but the idea remains the same. We call it double buffering. To achieve it, we use writeConsoleOutput function from Win32 API. It will help us move all of our characters and their attributes from our memory buffer to the console buffer. This function comes from kernel 32DLL, along with another one, createFile, which we'll use to obtain the handle to the console window. And here, you can see how we expose them to our C# application. We also need few structures that we'll have to pass as parameters. The important part is that they have to mimic the memory layout of their Win32 counterparts. I will be covering this in more detail in a future series. You can also check the Nostalgia engine source code. This specific bit is a part of the screen buffer class from the core directory. Anyway, Win32 API also provides other functions that allow us to change console buffer size, font type, character width and height. We can even define the RGB value of each color in this 16-color palette. There's one important limitation though. Windows console can only display 16 colors at one time. So one of the challenges that we face is to find some workaround to produce greater color depth. Like this. So we have some trade-offs and few tricks used here. But they aren't particularly complicated. Still, I think they're quite effective. You probably already know most of them and can figure out the rest by simply looking at the code. Nevertheless, I will expand on this in a future tutorial series. So there's a bunch of code needed to allow C# applications to talk directly to the console. And this includes fast unbuffered input handling, which C# console is not really good at. There are also commonly used graphics routines and algorithms. We also have sound, resource management, and resource files, like models and textures. Then we have scene abstraction so commonly used in game engines, and many other smaller stuff. And it can be neatly packed in a library or a game engine. And this is what Nostalgia Engine is, a library for doing silly things in a console. It's open and transparent and can be used in parts or as a whole. It's still a bit of work in progress, and I gradually keep adding more stuff, but I think it's usable at this point. It also supports texturing, sprites, OBJ models, simple lighting, and even has support for arithmetic operators on color palettes to achieve fancy effects like fade-ins and fade-outs. There's also basic ASCII GUI like Windows text boxes, open and save file dialogues, etc. Rasterizer, raycaster, and texture editor are extensions which are bundled along with the engine. And this is to make it more modular, so parts that might be irrelevant for a particular application can be simply removed. There's also plenty of demos bundled together, including everything shown here. The engine supports only basic sound beeps, but I started working on a sound synthesis. There's a great tutorial on this subject by One Lone Caller, and I'm sure it will be of huge help. I should also mention the separate tool for converting images from full-color PNGs or JPEGs into the format that Nostalgia Engine can understand. If you remember, we only have 16 colors, so we have to be creative. There's quite an interesting algorithm involved called k-means, which my tool uses to find the 16-color palette that represents the converted image best. We also have brightness component that we calculate in HSV color space. I will cover this soon, but for now you can find all of the code on my GitHub. This includes my basic C# implementation of k-means algorithm, which shouldn't really be too hard to follow. Anyway, I will eventually add more comprehensive documentation as I go along with the series. I hope you enjoyed this little intro and find the code useful. For the remainder of the video, I will leave you with some demos. Thanks for watching.
you.